All right, let's take a look at the two theorems that are on your page there. The remainder theorem, which we talked about yesterday. So f of c, just let's look at this again. Maybe it'll make a little bit more sense today here. Okay, f of c, okay, is equal to c minus c times q of c plus r. Well, this is 0. That all cancels out, so f of c is equal to r. So if you want to find a functional value, if you want to find f of 4, f of 3, or f of 5, you could divide that number in, and whatever you get for the remainder is what f of c is equal to. Okay? So that's the remainder theorem. So another one is I think useful is the factor theorem. So it's really saying that for a polynomial f of x, if you get a remainder of 0, then the function or the expression that you're trying to divide in is a factor. Well, we know that. Okay, is this a factor of 16? No, because the remainder is not 0. The remainder is 1. So unless the remainder is 0, that divisor, this is the divisor we're talking about. The thing that we're trying to divide in there, the thing we're trying to see if it's a factor of it. Is this a factor of this? No, because when you divide it in as a divisor, it doesn't divide in evenly. Okay? So, is x minus 2 a factor of that? So we don't want to do long division. We want to do synthetic division. So 1x to the third, 0x squared, 0x minus 8. Bring that down, multiply, add, multiply, add, multiply, add. So x minus 2 is a factor of x cubed minus 8. Okay? Now remember, for this to be a factor, 2 is a solution. Also, 2 is a 0 of the function. Like, so if we said that f of x is equal to x cubed minus 8, okay, would 2 be a 0 of the function? Yes, because you plug 2 in, it makes the 0. Okay, is 2 a solution of this equation? If you put 2 in there, would it make the equation equal 0? Yes, it is. So zeros, solutions, and if you have the opposite here, factor, those are the same thing. Okay? So over here, the question is 5 or I, we're going to do 5 first, is 5 a factor or is this 0 of this? So for 5 to be a 0, x minus 5 would have to be a factor. So people always wonder, when do I switch? The only time you switch the sign of the number that you're dividing in here is if they're given the factor to you. Or if you have the solution and you want to find the factor. That's when you go back and forth. So do we switch it here? We don't even need to really talk about this. Do we switch it? No, you put that number in there. If you get a remainder of 0, then it is a 0 of the function. So is 5 a 0 of that function? No. Now, this next one's going to be a little tougher because we're going to have to deal with imaginary numbers. Okay, so the next question is I a 0 of that function? Well, let's find out. We're going to divide I into f of x. All right, so we bring this down, we multiply. 1 times I is I. So I might even go like this. I'll put the I separate. I'll add these together, but you can't add real numbers and complex numbers, real numbers and imaginary numbers. So we just keep them separate. Now all I got to take this times both of these, so that'd be negative 3i. And I times I is I squared. And we can change that in our head and make that negative 1. Now we add these two together and you get negative 3i. And we multiply I times negative 3i, and that would be it'd be a negative 3i squared. negative 3i squared, which is positive 3. This is equivalent to positive 3. Negative 3 and positive 3, 0. So kind of weird. I is a 0 of that function. Okay? So that's all you're doing today. You're checking to see if things are zeros of the function or if they are factors of the function. But it's really the same thing. Only change it if it's a factor to the number in the corner there. Okay, good luck.